All right, so today we're going to be talking about drawing conclusions from data. So remember, we started with analyzing data and eventually wanted to get to the point where we can use that data to draw conclusions, which is really what the whole basis of statistics is about. There's like a lot of keywords we're going to get into today, and there's a couple different formulas, but I'm going to try to keep this as simplified as possible because I understand how this can be an overwhelming kind of topic. Okay, what I want you to focus on today is the idea that we want to make that normal interval. Okay, remember from yesterday we were talking about a normal interval are values that fall within 2 standard deviations of the mean. Okay, so stuff that falls between -2 and 2 in terms of z-scores, or like again based on standard deviations, 2 standard deviations above or below the mean. Things that fall within those windows are going to be what we refer to as normal values. Things that fall outside of that window is going to be considered an abnormal value. So if you take a look at example number 1, okay, a student doing a project on how long it takes for an 11th grader to run a mile records mile times for every 11th grader at his school and finds the mean time for an 11th grader to run a mile is 7.9 minutes. So the mean is 7.9 minutes with a standard deviation of 0.5 minutes. Okay, so again, we want to calculate what's 2 standard deviations above, what's 2 standard deviations below, and you're going to make that window because that's going to be your normal window or your 95% confidence interval. Okay, that's what we're going to refer to as the normal interval. Okay, so how are you going to be able to calculate that? So you're going to take your mean and you're going to add 2 standard deviations. You're going to take your mean and you're going to minus 2 standard deviations, and that's how you're going to create this normal window. So if I take 7.9 and I add 2 times 0.5, I get 8.9 as my higher value. Okay, if I do 7.9 minus 2 times 0.5, I get 6.9 as my lower value. So anything that falls within this window of 6.9 to 8.9 is considered the normal interval. Any values in here, now I will point out 6.9 and 8.9 are not included in that. So if someone ran a 6.9 minute mile, they would actually be considered abnormal. Okay, even though it's right on the border, it's not included in the interval. So it says an 11th grade student ran a mile in 6.8 minutes. So since 6.8 is not in the normal window, normal interval I should say, this is not a normal score or a normal mile time. Okay, so in this case, because you're talking about times, the person who ran 6.8 minutes is abnormally fast, according to the data that we've collected. Now, this is technically talking about population data. There's a whole thing about sample data, but I feel like this part gets kind of confusing, and we want to try to, again, keep it as simple as possible. So you're going to make a you're going to make a normal interval by doing mean, I'm going to do it like this, mean plus 2 standard deviations, mean minus 2 standard deviations. That's how you're going to make your normal interval. So if I'm going to skip ahead to example number 4, and then I'll go back to something else in just a second. It says Elizabeth waited for 6 minutes at a drive-thru at her favorite fast food restaurant the last time she visited. She was upset about having to wait long and notified the manager. The manager assured her that her experience was very unusual and it would not happen again. A study of customers commissioned by the restaurant found an approximately normal distribution of results. The mean wait time was 226 seconds. So keep in mind, this is in seconds. This was in minutes. So we'll have to convert this over to seconds for a second, and you'll see that this comes out to be 360 seconds. Okay, so the mean wait time was 226 with a standard deviation of 38 seconds. Given these data and a normal interval, that's what I want you to think of this as, 95%, is her wait time actually unusual? Okay, so as I just said, to make a normal interval, you're going to take the mean and you're going to add 2 standard deviations. You're going to take the mean and you're going to minus 2 standard deviations, and you're going to make a window out of that. So your mean wait time was 226 plus 2 times 38, that's our standard deviation. 226 minus 2 times 38. That comes out to be a value of 150 on the lower side and 302 on the higher side. Okay, so normal wait times should fall between 150 seconds and 302 seconds. So Elizabeth's time of 360 seconds is actually an unusual value, okay? So she is justified in claiming that her time was an unusually long time, okay? So her wait time is unusually long because it is above the normal interval. Okay, so I want you to think of this idea of mean plus 2 standard deviations, mean minus 2 standard deviations as one of your major ways of making a normal interval. I do have to talk to you about what happens if you have a mean proportion instead of a mean value, because it gets a little bit different, but the fundamental idea is still the same. Mean plus 2 standard deviation, mean minus 2 standard deviation. Okay, so in some cases, you don't have an actual mean provided, okay? You have a proportion instead, like a percentage of people that fit a specific characteristic. And from there, you can create a standard deviation. This is what this stands for. You can make a standard deviation using this specific formula. And then once you do that, you're still going to do a confidence interval by doing mean, okay? Well, really, I should do it in this case. It's not going to be mean. It's going to be P, okay, plus your standard deviation. Let me say that again. You're going to make a confidence interval that comes from P minus your standard deviation to P plus 2 times your standard deviation. And you're still going to do it the same way we did before, okay, except for the fact that, like I said, calculating the standard deviation is going to be a little different. In this case, you're going to have to use this formula, and it's going to be centered around P instead of a mean. It's a mean proportion. Okay, a college psychology professor theorizes that 45% of her students spend at least 15 hours studying for her last exam. So this is her claim that we're going to be testing to see if it's normal or abnormal. Okay, so we'll come back to that 45% in just a second. She conducts a survey and finds 19 of her 50 students spend at least 15 hours studying for the exam. That's the proportion that we're going to be working with. That's what we're going to center everything around. So your p-value is going to come from doing 19 divided by 50, which comes out to be 0.38. Now, technically, I should really be calling this p-hat. It means the mean proportion if I want to get into technical statistic terms, if you will, but I'm just going to refer to it as p for most of our calculations. So we want to forget about this whole calculate the margin of error thing. I'm going to go right to making the normal interval, and I want you to show you how you do it with these proportions. So we're going to have to calculate the standard deviation. So my p-value is 0.38, okay? I'm going to need 1 minus p, or like the not p-value when we thought of it in terms of probability. So that's 0.62. We also need to know how many people were in the sample that she, studied, and that was 50 students. So the standard deviation in this case is going to come from the square root of p times 1 minus p divided by n. That's how you work with it when you have a proportion or a percentage. Okay, and how would you know this? You would look through your problem and you would see nothing about the word mean beforehand. Okay, so when I do this calculation, I'll do square root of 0.38 times 0.62 divided by 50. Okay, and that comes out to be 0.069. Okay, so that's my standard deviation in this case. So now when I go to make my normal interval, normally you would have done mean plus 2 standard deviations, mean minus 2 standard deviations. This time you're going to do p minus 2 standard deviations and p plus 2 standard deviations, and that's how you're going to make your normal interval. So p is 0.38 minus 2 times 0.069, and then 0.38 plus 2 times 0.069. Okay, and so when I do that calculation, I'm going to get 0.243 to 0.517. Okay, that's the normal interval in this situation. So that's talking about 95% of students spend at least 15 hours of studying for the exam. The percentage of students that actually spend at least 15 hours studying for the exam falls between about 24% and 51%. So comment on the professor's claim that 45% of her students, the professor's claim is valid because 0.45 is within the normal interval. Okay? So again, this is an example of one where you're using a proportion instead of a mean and a standard deviation. So I want to remind you again of the one we just did as an example before. You were actually given mean. You were actually given standard deviation. That's how you go right to making that normal window. When you're dealing with percentages, you don't oftentimes have the word mean and standard deviation given, which is why you have to do this P kind of thing. So it says right here in example number 5, the school newspaper at a large high school claimed that 75% of seniors were in favor of assigned parking spaces. So this is the claim that we're going to be testing. So you're going to leave 0.75 until the end and see if it falls in the normal window. A random sample of 200 seniors were surveyed, and 120 of them said they were in favor of assigned parking spaces. So your p-value is going to be the 120 out of the 200 seniors that were surveyed, and that comes out to be 0.6, okay? So P is 0.6. So we're going to center our window around that 0.6, and we're going to create, again, kind of a standard deviation, but in terms of proportions. So we're going to need 1 minus P, which comes out to be 0.4. You need to know how many people were surveyed, so that would be 200. So when we make our standard deviation, that comes from the square root of P times 1 minus P divided by N. So the square root of 0.6 times 0.4 divided by 200. So when I take the square root of 0.6 times 0.4 divided by 200, that comes out to be 0.035. That's my standard deviation. Okay, so you're going to do P minus 2 standard deviations, P plus 2 standard deviations, and that's how you're going to make your normal interval. Okay, so my p-value is 0.6 minus 2 times 0.035, and then 0.6 plus 2 times 0.035. And so in this case, that's going to come out to be 0.530, and this is going to be 0.670. So that's saying that the normal percentage of seniors who actually in the whole population actually believe that there should be assigned parking space is somewhere between 53% and 67%. Okay, so that's what the true value should be. This claim of 75 is not in the normal window, so the newspaper is not justified in their claim. Okay, so you would say since 0.75 is not in the normal window, okay, the newspaper is not justified in their